Hello and welcome to the world of NDE 4.0. My name is Johannes Vrana and today we have a great guest, Naveen Nair. Naveen is Global Director for Technology and Operations at one of the biggest companies for NDE, for Waygate Technologies. Now, I guess you know, back in 2019, Waygate was still called GE Inspection Services, as far as I remember. Then they became Baker Hughes, and 2020 they built Waygate Technology, which is actually a division of Baker Hughes. He's also chief of staff to the CTO, Arungalai Anbarasu. In his past, he was director for engineering and for strategic partnerships. He was R&D manager for ANSYS, and he's actually a mechanical engineer, and he holds a PhD in electrical and computer engineering. Now, but what we will be talking about today is one of the programs Waygate is developing, which I learned about only a couple of weeks ago. And that already dates back a couple of years when they started with the development. But it's NDE 4.0. So that's why I invited them. I invited Waygate to show it here on the YouTube channel and to share it with all of you. So Naveen, that's your place.
Thank you, Johannes. It's a really great pleasure to be here. And if I may offer a small correction. So in the past, I think most people would know, in the past, we were, as you mentioned, GE Inspection Technologies. We actually did have, as was the case with a conglomerate like GE, a different group in GE called GE Inspection Services. So I wanted to make sure that we did not confuse the two. So that happens when you have a company with over 400,000 different pieces of it running around. But I think we were GE Inspection Technologies, and prior to that, we have been lucky, honored to have held several historic and heritage-filled brands like Kraut-Kramer, like Seifert, like Phoenix, and Everest, which have in their own rights been the world leaders in the technology. So everybody, I guess, who can spell NDE also can probably spell Kraut-Kramer, who very literally wrote the book on ultrasound testing. Also Seifert and Rongen, who practically discovered X-rays and X-ray technology. So we're lucky, and we're very honored to have these brands as part of our portfolio. Today, we have rebranded our overall company as Waygate Technologies, but we still hold to that tradition, hold to that heritage. And I think part of the challenge for us is to drive that heritage, drive that history, while transitioning into something as exciting and as forward-looking as NDE 4.0 to drive a transformation, a revolution in this company. So we want to, have the Renaissance masters in the place while we advance to the next industrial revolution. I think that's really our goal. So ride on the laurels and then still develop really advanced technology for our customers. So I think with that, I will jump right into a quick introduction of where we stand today. So we are headquartered in Germany. We have a significantly wide global footprint. I like to tell people that as the global technology director, I have an extended team that sits across, 3 continents, 6 sites in five different countries. So it's a really lucky and diverse opportunity that we have. We have development areas. So engineering is closest to my heart, of course. In the US, in Skaneateles, a very beautiful place in upstate New York. We also have 3 sites in Germany, very close to you, Johannes, and a site in China, a site in India, and a site in Shannon in Ireland. So if there's anybody out there who is really excited about NDE and loves to travel, I think this is a good place for you once the COVID problems are over. We are a global leader in non-destructive testing solutions. We have over 10,000 customers worldwide and over 125 years of NDT experience, as I alluded to earlier. a long history, long heritage. Um, we our goal is primarily to drive insights and innovations using NDE, and as we say, we offer fundamentally we offer peace of mind. Yeah. So we have an advertisement that I do not know if you've seen, but it's on the on YouTube, which talks about how we obsess over the things that nobody wants to think about. So why do planes land safely? Everybody worries when a plane does not land safely. We worry that every plane does land safely, and we do the inspections that make sure that your cell phones don't blow up in your pockets, and we do the inspections that ensure that your car doors are closed and your ABS system works. And so we have inspection systems. We have customers who spread across the industries, from aviation to automotive to electronics to consumer electronics. Like I said, the cell phones in your pockets to the aircraft engines that you fly on. So we have a gamut of technologies. We primarily orient along three technology verticals. So radiography, X-ray, CT, film, by the way, tubes and generators, components, etc. We go on the ultrasound vertical. We have everywhere from flaw detectors that can fit in the palm of your hand to ultrasonic testing machines that can test entire rails and bars that are 50 to 60 feet long. So we have the entire gamut of instruments and machines there. We also have a very strong play in the visual domain, where we build video boroscopes, fiberscopes, and cameras that inspect, for example, aircraft engines. So we have boroscopes that, and I love this example. So this is a 6 mm boroscope. uh, think about it, that goes into an aircraft engine while it's still hot, so on the wing, just after the plane has landed, and it can go inside through a port on the engine side and look at a blade and measure a crack on the blade in the third dimension. So I'm not talking about a 2D camera, I'm actually talking about a stereoscopic camera that can measure a crack on the blade at an accuracy of 50 micrometers or less. So this is really cool technology that we have. And so we run we have run over the past several years hardware instruments across this gamut. Um, but today we are also expanding into software, we are expanding into process optimization, process evaluation, and of course, service offerings. So that is my Waygate spiel. So if that doesn't make you excited to come and join us, that should at least make you excited to buy our products. And if you have an interest and a credit card ready, please call me. Um, what do we want to do? So this is where really our NDE 4.0 play comes into picture. So we, as I said, probably ad nauseum, we have industry leading inspection devices today. And our principles on building these devices have been along these 5 different, I would say, thrust vectors, right? So we want to make the invisible visible. That's what we call it. So essentially, what we want to do are see more defects, higher probabilities of detection, higher inspection quality. We would like to enhance the speed of inspection. So we want to help people get to their results faster. If you have an airplane that's sitting on a ground with an engine being inspected, it costs roughly 200K to keep that airplane on the ground every 6 hours. So we want to change that. We want to make that faster. We wanted to help with the decision making, so make it assisted, make it automated, reduce human error, reduce human fatigue problems. We want to connect fleet and inspection data, and we want to automate inspection processes. So that was our core till, as you mentioned, Johannes, maybe 2-3 years ago, and that is still a large part of our core today. So this is where we build instruments, we build onboard software, we build onboard analysis, etc., etc. However, we really see an opportunity and an opening to go to what we call industry leading inspection solutions. So really not just build devices that answer a specific inspection problem or a quality problem, but really build a solution that can help our customers advance beyond that and drive innovations, drive true leading edge improvements to their process, to their performance. And I think it all comes down to something that we heard from one customer, actually one person at a large automotive company. When we went to him, so as we were developing the strategy, and we asked him, hey, what can we do to make our inspections better? And he said, actually, I don't care. You can do whatever you want to do to make your inspections better. My problem is not that I don't have a good inspection system. My problem is that I need inspections to begin with. So he said the cheapest and the fastest and the best and the most efficient inspection system to me is still a waste, because I want no defects. I don't want to detect defects better. So that really inspired us to come up with what we call the Waygate promise, and I'll talk about it in a slide here. So today we call the Waygate promise, which is really our promise to the world or to the transformation of NDE 4.0, as the taking the customers from detecting defects to avoiding defects, because that is really what a customer wants. So a customer, whether it is an automotive manufacturer or a battery manufacturer or a cell phone manufacturer, they are not interested in the best detection system. They're interested in not having defects to begin with. And we really believe that by doing three fundamental things, and that is what you see on the right side of the slide here, or the left slide, depending on how you're looking at it, is really three different things that we want to do. We want to offer edge insights. So going from devices and applications, we want to offer analysis and insights on the edge. So really on the device, we want to be able to make your life better, make your life easier. We want to be able to connect all our devices together, and we want to do this across our modality. So what you see there are three instruments. One is a visual one is an ultrasound, one is a CT machine. But we really want to be completely agnostic to modalities, to inspection methods. We want to be agnostic to hardware. So we really want to even connect our competitors hardware, because we believe there is value when we democratize that kind of analytics and capabilities for data. By connecting all of this, we would like to build what we think of as data platforms. So two fundamental data platforms. One is an inspection data platform, which really is about storing, servicing, managing our inspection data. And we want to do this, and we are doing this, by the way. We have software out there, as you mentioned in the introduction. We've been working on this for a couple of years now. We today have a data platform that we call Inspection Works, that actually manages to connect data from inspections independent of the kind of inspection that is done, all tied to an asset. So what that means is, if I am inspecting, say, a blade, I should be able to collect all the data from that blade and all the inspections that the blade has gone through in its lifetime together in one place, that 3, 4, 5 years from now, when the blade is in service on some engine, on some airplane, I can look back just by looking at the serial number of the blade, understand all the inspection history of that. So people call that a digital twin, people call that a digital triplet. I think really that is what our platform will provide. We also have a system data platform, which is really about monitoring and maintaining our devices. So device status, the log files, the system state, because these two tie together to give you what is on the top of the tree, which is advanced analytics and analysis, really, which is really about predictive maintenance, which is really about allowing you to have decision engines that will decide for you how to improve your process so that you start reducing your defects. So with, so if you are able to do this, so what I show here really is a I mean, it's the life cycle of a blade on a slide, huh? So I tend to compare this to saying it is like taking a human being's life and putting it in one sentence. So this is obviously an oversimplification of the whole exercise, but I think it serves for a good example. So if you look at an engine blade, this engine blade starts typically as a titanium rod or a bar. Um, and today we inspect that using, like I mentioned earlier, we do some ultrasound testing on it. We could inspect if it's coming, in this day and age, if it's coming out as, for example, a powder, we can inspect it using CT. But we do an inspection of this raw material, if you will, and then it goes through several manufacturing processes. It goes through typically a casting process, typically a machining process, and then pressing, coating, and finally installation on an engine. So during this entire manufacturing or production process, we also inspect this at each stage. So we, by the way, inspect and this is all inspections we do today. I mean, this is not NDE 4.0. This is just, I guess, NDE 3.0. So we do inspections of the wax mold for the casting. We do inspections of the cast parts using X-ray. We do inspections of the machined part using X-ray and ultrasound. We do inspections of the coating using ultrasound. And then once this is done manufacturing, we put it into an engine, if you will. This engine gets onto an aircraft that people fly in. And this goes through what we call as in-service inspection. So every so many cycles, it gets inspected on the wing. It gets inspected during scheduled maintenance, what is called C checks and so on. So these are inspections that we do using boroscopes, using ultrasound again. So this is another set of inspections. This is all the same blade, remember. And then finally, when this engine needs to be overhauled, or when the airline wants to switch engines, they send it back to the service shop and they do an overhaul. During the overhaul, they do what is called a D check, which is really a complete disassembly of the engine and then checking each part. And we do inspections at that stage also. And all of this ties into our inspection works platform, where all of this data is completely captured and it is structured. What that means is we connect, like I said, we can pull out a blade part number and follow its life through the cycle based on inspection. So that is why people tend to call it a digital triplet, because the assumption is that this blade has a digital twin. Yeah. So as it goes through, there is a modeling that should happen, and that is really manufacturing 4.0. So people would build a digital twin of the blade as it goes through its life cycle. To go through the same life cycle, we build an inspection thread which follows the inspection, which follows the quality level of this blade throughout. Now, that is really, in my mind, the first half of the story. So you have, and by the way, this delivers a tremendous value to customers, because now customers have the ability to connect all these inspections. We have the ability to do really cool stuff. Like, for example, let's say so for people who fly or start to fly once COVID is gone, it might be surprising for you to know that a lot of the aircraft we fly on have engines that have blades that have small cracks on them. So if that scares you from flying, then I'm sorry, but they do. Because most of the times when you see a crack on an engine blade, it doesn't really mean much. It means that the aircraft can continue to fly. It just needs to be checked again in so many cycles or whatnot. So there's a lot of safe limits under which you're allowed to fly, even if you have small flaws on your blades and on your engines. However, what would really be useful is if you could have the full history of the blade, you can actually predict when the next maintenance check will be required. And that really saves a lot of time, a lot of effort for our customers. And so just having this thread is really a big use. So, but what really I'm sorry, what really gets you to the next level, to truly 4.0, is what we call the virtual loop cycle. And what does that mean? That is really a point about where we take all of these threads. So we connect all our devices, we manage all our data, we drive advanced analytics. Like I said, we can look at, the history of a blade, look at the analytics of how that fleet of blades behaved, and see whether we can predict future maintenance needs or future defect propagations. But we can also tie all this back into a virtual loop where we actually impact the design of this blade. So we can take the life cycle of a current product and really impact the design process of the next generation of that product. So this is really where I think NDE 4.0 comes into play. This is really where we can drive a value that is what I think of as just like compound interest. Yeah. So people who are saving for retirement are familiar with this concept. You save $1 today, you really get much more than $1 tomorrow. And this is what I mean by compounding value. So by looking at inspections of one part today, you can really affect multiple generations of parts in the future. And that I think is value that is transformative. And if you want to talk about, so NDE 4.0, at least I imagine, comes from the concept of the industrial IR 4.0, so the industrial revolution, right? So this is where we go from a simple improvement to a true revolution in value. So, and that is where we tie in, as I said earlier, the Waygate promise. To us, the revolution here is the fact that we have a company that is built over 125 years on detecting defects. And the next 125 years, we want to go to helping our customers avoid defects. So I think, honestly, I could go on about this, but I want to give you one concrete example where this is really being applied today. So we actually have a lab system in our company that implements this for additive manufacturing. Why additive manufacturing? Well, first of all, because it's really cool. Secondly, because we also think that this is something that the manufacturing process is so young that we have the ability to influence it a lot. So if I walk into a aviation casting company and suddenly tell them that I want to change your casting process, they'll probably laugh me out of the door. But if I walk to an additive manufacturer and say, I would like to improve your manufacturing process, they tend to listen a little more because, like I said, they're very young. They have not been casting aviation parts for the past 100 years. So what we do here is really look at the CAD data, look at the design data for an additive manufacturing tool, additive manufacturing part. We look at the printing mechanics, we look at the printer parameters, and then we predict what kind of defects could occur in the part. And once we do that, we at the end of the production, we actually look at CT data from the part and look at the actual defects and compare them against our predictions. And when we find differences, when we find that our parameters are too strict, we have discovered that we are able to then go back using this defect information and reduce, for example, tolerances in our machines, in our designs, reduce, for example, the amount of in-process inspection that is needed. So we actually make the design process faster. We actually make the manufacturing process faster by driving innovations from the inspection. So that is really the what we call the virtual loop of quality, right? So like I said, we look at the inspection of one part and we're able to actually make the manufacturing process for the next part faster, easier, simpler, and make it less defect prone. And that's where I'm going to stop, because I think that is the powerful message that I want to leave everybody with, is really saying that there is an opportunity for us here. There's an opportunity for all of us in this in NDE to really take defect detection and move it to the next level, which is defect avoidance. And I think that would be transformative. I think that would be dramatic. And we are excited to be on this journey. And we are excited to invite our customers, excited to invite our partners to join us on this journey with us. So that's where I'm going to stop, Johannes. And yep, I will take questions or however we want to go for this.
Naveen, thanks a lot for that presentation. Now, I have a couple of questions for you, which I will direct to you in a minute.
Sure.
But here, a short announcement. We will actually have another video with Naveen, with myself, with Aru, who's CTO of Waygate, and with Ripi. And the four of us will actually discuss your questions. So if you have any questions, write them down here in the comment section or on LinkedIn or on any other platform, and we will be discussing, the four of us will be discussing your questions. Now, coming a little bit back to Naveen's presentation. Now, I think this is a really good example for what I always like to call NDE for Industry 4.0, which will be moving NDE from just this tool to give you a good bad decision into becoming most likely one of the most valuable data sources for Industry 4.0. By using the cyber physical loop, by using something to collect all of that data, to process it in a digital twin, and finally to gain knowledge out of that, which finally leads to the point that we can improve production, improve design, and improve maintenance. Now, one thing I want to discuss with you definitely in our video we will be doing in a couple of weeks will be, we have to talk about that word digital triplet.
Yes. I think, like I said, I think it is a correct term. It is also a little bit tongue in cheek because everybody talks about the digital twin. So where do we go next?
Yeah, I'm not so sure that the word digital triplet is already, I think what we are discussing is really a digital twin, but we can talk about that next time.
Oh, absolutely.
Now, my question to you was, from my experience, if we are talking about cyber physical loop, if we are talking about using all data to improve production, usually this requires data from a lot of different places. It's all it's sensors, it's data from ERP system, from MES system,
yes.
from NDE for sure. And the idea which I normally heard is using the industrial Internet of Things to bring all equipment from all different kinds of suppliers together so that kind of all of the data can be merged into one single namespace. And then all of that finally can be processed in a digital twin.
Yes.
Now, my question to you is, with NDE, we are one of the players, and you are a big player, therefore you can actually offer perhaps a lot more than perhaps some of the small players, but still you cannot actually have all of those puzzle
Absolutely.
pieces
Right.
just for yourself. So my question is really, how will you interact with the industrial Internet of Things? What's your idea for that?
Right. So I think first of all, that's an excellent point, and it's also a very interesting concept, because I think one of the biggest pushbacks we used to get early on, and I'm being absolutely open about this, right? So one of the interesting pushbacks we used to get early on from our customers is, hey, you do inspections, yes, granted, and you're your Kramer, your Seifert, you're really good at inspections, also granted, but you do not know how to build a blade, and you have no clue how to run a pipeline. So don't I mean, why would I trust you with improving my pipeline process, or my blade manufacturing process? Yeah. And I think the way we address that is very simple. I hearken it to, for those of you who are in the software world, the development of, for example, Linux. So Linux builds a kernel. Linus Torvalds does not build, you know, Ubuntu, for example. But what does he make that kernel do is that kernel can talk to every single piece of the ecosystem. And so our data storage platform, our data management platform, has two unique features that make it perfectly suited for this. One, it is completely accessible via APIs, both back and forth. So we enable access to all our data via an API, and we have inbuilt anonymizations and inbuilt capabilities where the customers can share data, in fact, with even other customers, who are their competitors, because they would share just the relevant portions of the data. They can choose to do what they want with the data, and they can choose to write routines from their ERP to collect pieces of the inspection data that they want. We also have, on the other side, like I mentioned earlier, the ability to connect everything to an asset. So if you think, and that was very consciously decided, because if you look at the manufacturing of a product, it also goes by an asset. So you manufacture a blade, and you, in the manufacturing process, you can track that blade throughout its life. You are running a process or through a pipeline. On the pipeline, everything can be tied to it. You can look at the flow rates, you can look at the temperatures, you can look at the product that is flowing, you can look at the history of the pipe, you look at the support structure of the pipe, etc., etc. So by tying all our data to an asset, we almost inherently enable this kind of a tie-in to every single other process that exists, and set ourselves up prime for really this kind of a cyber physical loop, as you call it. So I think it is these two key features. One is the ability to be, to open access to everything as needed by the customer for through an API structure that is very rigorous, very well maintained, and very well documented. And the other is by driving this kind of a context to all our data. So instead of so people, the first naive question I get when I first make this presentation to somebody is, how is this different from, a box folder or Dropbox or something where I just dump all my data? And truly, the point that we drive is the context. Yeah. So we tie everything to a context of the asset, and that contextualization helps in attaching it to, like you mentioned, any other piece of data that comes in.
Yeah.
The third, by the way, that I think I've mentioned multiple times, is that even our platform itself is completely agnostic. So we can attach any data to that. So today, people take pictures on their cell phones of blades, of turbines, and upload it to our site, and we attach it to the same context. So a blade can have a cell phone picture, a handwritten piece of note, a post-it note, uh, ultrasound inspection, B scans and C scans, and it can have a CT volume, all attached to the same blade number or a blade part number, and really drive that kind of an asset driven data structure, irrespective of what data you feed into it. So that is really where we play in the ecosystem. And like I mentioned the example of Linux earlier, I think it is about how, in Linux it's easy, right? It's open source and period. So we don't quite make, I mean, I don't want to use the same word because that is honestly not what we are. We are truly open enabled is what I think to like to call it. So we enable, we look at ourselves as an enabler for all of these processes and capabilities, and we drive that by creating as open a structure as possible.
Ah, I think that is really showing that the NDE industry is kind of giving, or in the process of perhaps giving up some of the proprietary way of thinking we were doing in the past for, I guess, all of us, and going a little
Yeah,
bit more to
right.
a little bit opening up.
Right, and Jonas, I think one of the things that we have to accept in our industry, and I think people are getting there. Don't get me wrong. I think it is only fair. Huh? So I always use this joke, right? I mean, yeah, we go to somebody and they say, no, I cannot share my data with you because it is highly sensitive and highly secure, and I don't want to tell you what it is, and I cannot show you the data. You cannot look at it. You have to close your eyes when you walk into my factory or my company or my platform or my website, whatever. And then they go back and send an Gmail about it to somebody else. So I mean, I think it is just again, it is about context, right? When you start talking to people, sitting next to a machine, looking at a part or taking an X-ray, somehow we are all very sensitive about it. But we also do very similar things on completely open platforms, and we tend to be comfortable with that, and it is our job as the you know drivers of this to ensure that level of comfort is available to our customers. So which is why, like I said, we started out building what we call anonymized APIs. So if a blade, for example, or a pipeline inspection data has, say, 800 tags, all the way from the customer name to the inspection date and so on and so forth, our customer today has the ability to dictate what tags are visible even to us, by the way, and what tags are not. So for in the extreme case, we would literally just see a model of the pipe and where the defect was, and nothing else. And it could be a pipe that is carrying water in South Africa to carrying sensitive nuclear waste in Siberia. I mean, it could be anything really. So we have the ability to provide that kind of an anonymization, and we recognize that. I think as providers of these tools, we have to understand our customers' sensitivities and understand our customers' problems and work within those constraints. But it's a two-way bridge, two-way street, right? The customers also are starting to recognize that there is value in open data, and truly, the prowess of data. So our CEO Nicola has he always says the power of Twitter comes not from Twitter, but the fact that people are tweeting on it. Yeah. So it's really about driving, the more open you are, the more open your access is, the more value you derive, not just as a provider of the platform, but also as the users of the platform. Imagine if your Twitter feed had 0 followers. That wouldn't really help. The
Yeah,
fact that your Twitter feed is good is because you have people looking at it. So if you wanted to keep everything secret, then yeah, you could do that, but you wouldn't get the same value out of it.
yeah,
So
yeah. Now this is will be kind of one of the next topics I will be addressing: data sovereignty and data ownership.
right.
Yeah,
No, that's
but I think we should be coming to an end. We are already at 35 minutes,
okay.
something like that.
I'm not sure
So
if that's good or bad, but anyway, I enjoy talking to you.
yeah, this is me too, and we will continue our discussion.
Absolutely.
So thanks a lot for giving this presentation. I think it was really a good view into that the big players in NDE really start getting on board on NDE 4.0. It
Yep.
is showing how valuable NDE data is for industry, how we can use all of the data to make more out of it, to get away from this, oh, NDE, that's just, yeah, we actually do not really need it. It's an unnecessary thing we have to do. It is not. It is most
Absolutely.
of the most valuable data sources for industry, and not only for industry, also for civil engineering, for everybody.
Absolutely. And I think, I think the key as we put it, is that we have been a cost center historically to people in the business world. We really are a value center, and it is behooves upon us to drive that transformation. So we are not just cost for you, we are actually driving value for you. and
Yeah.
and I think that is really where we want to where we see NDE 4.0 or NDE for industry 4.0 as driving that true value from each inspection. Yeah. and
Yeah.
and
This is exactly the main point of NDE 4.0.
absolutely.
Bringing the value of NDE to the customer. So thanks to all of you for watching
Thank
this
you.
video.
Thank you very much.
Give us a lot of questions, a lot of challenging questions, and we will discuss it. So thank you for watching. See you soon. Thank you and bye.
Thank you very much. Bye bye now.